Okay, we're going to do a couple of examples with radians here. So, say you want to find sine of pi over 12. Well, we need to write pi over 12 because it's not one of our special angles that we know exact values for. We need to write it in terms of our exact values. So, let's do a little chart over here. Smallest exact value is pi over 6. Okay, so that was 30 degrees. And then we have pi over 4. That's 45 degrees. Pi over 3. And that's 60 degrees. And let's go right to pi over 2. Okay, that's 90 degrees. Okay, so these are our special angles. Now, in order to figure out what pi over 12 it might be, we want to figure out what each of these would be with a denominator of 12. So let's write pi over 6 as 2 pi over 12. Pi over 4 is going to be 3 pi over 12. Okay, multiply top and bottom by 3. And then pi over 3 is 4 pi over 12. And then pi over 2 is 6 pi over 12. Okay, so each of these can be written as a pi over 12. Now, how can we get pi over 12 from any of these? Well, we've got pi over 12 equals 4 pi over 12 minus 3 pi over 12. Okay, so we can write that with our by reducing them as pi over 3 minus pi over 4. Okay, so pi over 12 equals pi over 3 minus pi over 4. Or pi over 12 can equal 3 pi over 12 minus 2 pi over 12. Okay, and 3 pi over 12, well, that's pi over 4 minus pi over 6. Okay, so we've got two options here for writing pi over 12. Okay, so pi over 12. Okay, we're going to break that up then into sine of pi over 12. We're going to use the first one. It's going to be sine of pi over 3 minus pi over 4. Okay, that equals, so we're going to use the sine A minus B formula. The sine of A minus B is sine A cos B minus cos A sine B. So it's going to have a minus in the middle. Okay, so sine pi over 3 cos pi over 4 minus cos pi over 3 sine pi over 4. Okay, so I'm just using the sine of A minus B formula. Okay, now from our special triangles, okay, so we know that pi over 4 is the 45, so the 1, 1, root 2 triangle. Okay, so if we look at the triangle with pi over 3 in it, okay, 1, 2, root 3. Sorry, it's over here. 1, 2, root 3. So the pi over 3 is 60 degrees, so pi over 3 is here. Okay, that would make this pi over 6. So sine of pi over 3, sine is opposite over hypotenuse, so it's going to be root 3 over 2. Okay, and cos of pi over 4 is 1 over root 2. So root 3 over 2 here, so minus. And then we got cos of pi over 3. Cos is adjacent over hypotenuse, so it's going to be 1 over 2. And times times 1 over root 2. And that's just going to be root 3 minus 1 over 2 root 2. Okay. If you're multiply top and bottom by root 2, you're going to get root 6 minus root 2 over 4. Okay, so that's that example. So let's try another example. Let's do cos of 7 pi over 12. Okay, so we need two angles that give me 7 pi over 12. So if we go back to our chart here, two angles that give us 7 pi over 12. Well, if we add 3 pi over 12 and 4 pi over 12, we're going to get 7 pi over 12. Okay, so that's going to be cos of 3 pi over 12 plus 4 pi over 12. Okay, and then we can reduce those. So 3 pi over 12 is just pi over 4. And 4 pi over 12 is pi over 3. So, and we're going to use the sum formula for cos. Okay, so that's going to be cos A, cos B, minus sine A, sine B. Okay, so there's A and B. So cos pi over 4, cos pi over 3, minus sine pi over 4, and sine pi over 3. Okay, so cos pi over 4 is 1 over root 2, and cos pi over 3 is 1 over 2, and sine pi over 4 is 1 over root 2, sine pi over 3 is root 3 over 2. Okay, and that becomes 1 minus root 3 over 2 root 2, which if you multiply top and bottom by root 2, you get root 2 minus root 6 all over 4. Okay, and that's a couple radian examples for compound angles.